Hello everyone and welcome back to the channel. In today's video, we are going to discuss the communication technologies which are required for an in-situ leaf area index monitoring system using the IoT. Communication is one of the most important parts of any IoT-based agricultural system because it helps transfer sensor data from the farm field to the cloud, mobile application or monitoring dashboard in real time. So let's understand the major communication technologies used in this smart agriculture system. Now here, this image illustrates the communication architecture of an IoT-based leaf area index assessment system used in the smart agriculture. The system integrates a wireless sensor network, then a IoT gateway, public land mobile network, that is a PLMN, then IoT cloud infrastructure, you have MQTT broker, then a farm management information system, FMIS, to enable real-time crop monitoring and decision making. Now at the field level, multiple ground sensor modes, which are represented by this capital G, are deployed below the crop canopy to collect the environmental data such as the temperature, humidity and the light intensity, that is the PAR. And a reference sensor which is represented by the capital letter R, it is installed above the canopy and it acts as the cluster head. Now the sensors are organized in the star topology where all the ground sensor nodes communicate directly with the reference sensor. The cluster head gathers and aggregates the data collected from the sensor sensor nodes, and the collected data or the information, it is transmitted to the IoT gateway, which acts as an intermediary between the local sensor network and the external communication networks. Now the gateway, it receives the sensor readings, perform basic processing and prepares the data for transmission to remote servers. To establish the communication between the agricultural field and cloud services, the system uses the public, that is a PLMN, which is called as the public land mobile network, and it refers to the cellular communication technologies such as the 2G, 3G, 4G and 5G networks. And this allows the gateway to send the data to cloud servers even when the field is located in the remote area without traditional wired internet access. Now within the IoT infrastructure, you have an MQTT broker which manages the communication between the devices and the applications, and the MQTT it is the full form of, that is message queuing telemetry transport, which is a lightweight publish subscribe messaging protocol specifically designed for IoT applications. Now this will ensure reliable and efficient data transmission while consuming minimal bandwidth and the power. The data received through the MQTT is stored and processed in the IoT cloud platform, and the cloud infrastructure performs data storage, analytics, then visualization and the LAI estimation. Then you have a farm management information system, that is a FMIS, resides within the cloud environment and serves as the central platform for agricultural data management. This FMIS analyzes the sensor data. It will generate the reports, estimates the crop growth crop growth conditions, and supports farm management decisions. Now finally, the processed information is delivered to the user applications including the computers, tablets and the smartphones. So the farmers and the researchers can access the dashboards showing real-time field conditions and the LAI trends like alerts, notification and analytical reports. Then here the communication architecture, it enables continuous monitoring, efficient data exchange and the data-driven decision making, and ultimately improves the crop productivity and support precision agricultural practices. So here this is the data flow using the MQTT protocol. That is, you are having the ground nodes, then you have the cluster head. These are passed to the cluster head, then the data is sent to the IoT gateway, then to the MQTT broker and next to the IoT or the cloud FMIS, and then reaches the user. Now here you can see you have MQTT protocol and you have the telos B modes. So here the MQTT, it stands for the message queuing telemetry transport. It is a lightweight publish subscribe messaging protocol. It is widely used in the IoT applications, and its lightweight nature makes it suitable for devices with limited memory, low power and low bandwidth requirements. Now here you can see several telos B modes are there which are displayed, and these are wireless sensor nodes that operate using the IEEE 802.15.4 wireless communication protocol, and the modes communicate with one another using a wireless sensor network using the where it is shown by this dashed blue lines, and these nodes collect the environmental or the sensor data, and it's sent to the it is sent to the central node, which is called as the cluster head here. Now the cluster head acts as a coordinator that gathers the information from all the nearby sensor nodes. Then the cluster head is connected to a gateway through a wireless LAN Wi-Fi network. The gateway serves as a bridge between the local wireless network and the internet. Okay, so or the cloud based IoT services. Now through this connection, the collected sensor data can be transmitted to an MQTT broker. So the MQTT broker is it is the central communication server, and it receives the published data from the IoT devices, and it distributes the information to the different subscribers here. Okay, so the publish subscribe model is highlighted clearly, where the multiple subscriber devices such as laptops, smartphones and desktop computers, these will receive the updates from the MQTT broker without directly communicating with the sensor nodes. So here this image it explains how the IoT devices, wireless sensor networks, gateways and the MQTT work together to provide efficient, scalable and reliable communication for IoT applications, that is for smart IoT applications such as you have healthcare, environment monitoring, then environmental monitoring, industrial automation and the smart cities. So this is about the communication technologies. Thank you.